I will start the class in 5 minutes. So, have you guys tried the assignment number three?
Yes, ma'am, but there are some doubts.
Okay. So welcome everyone. Welcome everyone for the live interactive session of the course Natural Gas Engineering. Today I'm going to discuss some sample problems which are based on assignment number 3. My name is Ananya Mandal and TA of this course. So let's start with the first question. What is the primary purpose of gas well testing? Options are A. To estimate the permeability of the reservoir. Option B. To determine the reservoir pressure and productivity index. Option C. To measure the rate of gas flow from the well. And option D. To determine the gas composition and properties. So any idea what will be the answer for this question? Shrishti?
Ma'am, option B.
Option B. Let's see. Yeah, option B is the correct answer. So the gas well testing is a useful tool to analyze the performance and forecast the productivity of any gas well. It gives the static reservoir pressure, flow potential of gas reservoirs, rate versus pressure depletion, and just to estimate well or formation properties including permeability, porosity, phase zone, skin factor, or damage. So that is the definition of a gas well testing. So option B is the correct one, that it determines the reservoir pressure and the productivity index. As it is given that it gives the static reservoir pressure and also the performance and productivity of a gas well. So the next question is, an oil well is producing at a steady rate of 2500 barrels of oil per day with a flowing bottom hole pressure of 1800 psi. The reservoir pressure is 2500 psi and the well's productivity index is 20 barrels per psi. So calculate the expected oil production rate if the bottom hole pressure is reduced to 1600 psi. So options are A 10,000, option B 20,000, option C 5,000 and option D 0. So here they are talking about the productivity index. So for initial conditions, the productivity index is already given to us. Now there is a change in the bottom hole pressure which reduces from 1800 to 1600. So we have to find out at this what will be the oil production rate. So productivity index is a commonly used measure of the ability of the well to produce. It is defined by the symbol J and it is the ratio of the total liquid flow rate to the pressure drawdown. So this is the equation for finding out the productivity index, which is the ratio between the total liquid flow rate and the pressure drawdown. And this pressure drawdown is the difference between the bottom hole pressure and the initial bottom hole pressure and the reservoir pressure. So reservoir pressure is also known to us and the bottom hole pressure is also known to us. So from that we can find out the oil production rate. So using the equation, it is given the productivity index is already we know that is 20. So multiplying it with the pressure difference, that is the new pressure difference, with the value of uh, the oil production rate, we are getting a negative. Now the negative sign indicates that the well is flowing backwards and will not produce any oil at the new bottom hole pressure. Therefore, the expected oil production rate at the new bottom hole pressure of 1600 psi will be 0. As so, whenever you are getting the value in negative, that means there is no, we will not be able to get our oil from there and it is moving in the opposite direction. So for that, the answer will be automatically 0. So option D is the correct answer. Any doubt in this one?
No, ma'am.
Okay. So Now this next question, there is a statement which will be used for next four questions. So the statement is that the gas well of diameter 6, 7 by 8 inches is being operated at a bottom hole pressure of 3100 psi under pseudo steady state conditions, producing 0.68 specific gravity natural gas without sour gases. The pay zone of the reservoir has a thickness of 72 feet and a drainage area of 125 acres. With an average pressure of 5200 psi, temperature of 160 degree Fahrenheit and effective permeability of 0.18 md, the average viscosity and average compressibility factor are given as 0.027 cp and 0.98. So the first question they are asking is to estimate the value of flow rate considering the pressure approximation approach using analytical expression, round off the answer to nearest tens. So there are few terms here that we have to know. So first they are asking the flow rate, and we have to consider that using the pressure approximation approach using the analytical expression. And another thing to note is that the condition is pseudo steady state. Okay, so we know, we have studied that at pseudo steady state and at steady state there are different analytical expressions according to the pressure range. That is, either the pressure is going linear, that is below 2000 psi, between 2000 to 3000 psi, and becomes constant after 3000 psi. So according to that, there are different expressions that are used to find out the flow rate for both pseudo steady state condition and steady state condition. So here we are considering a pseudo steady state condition. So for that, these three cases, which is pressure approximation approach, pseudo pressure approach, and pressure square approach. These three approaches need these equations we have to know. And the most important thing when you are solving the for flow rate is the units. So whatever unit is given in the question, you always have to convert those units to these units. So that is the most difficult part here, because once you change all the units to these specified unit, then you will get your values. Otherwise, you will get problem and error in your answers. Okay, so let's see the first one. They're saying we have to use the pressure approximation approach. So pressure approximation approach means this equation we have to use. So that's the equation they have used. Another thing, okay, so here they have also considered the skin factor and non-Darcy coefficient equation. This is the overall equation. But here they are not talking about the skin factor and the non-Darcy coefficient. So those values are not included here, as you can see in this term. Okay, so excluding these two terms, the whole equation will remain same. So that is the equation we are considering here. Now all the values are known to us. The K value, that is 0.18, which is the effective permeability. So K will be the effective permeability. H is the pay zone thickness, that is 72 feet. So as you can see, it has to be in feet. So they have kept this in feet. P dash minus PWF. P dash is the average pressure that has to be considered in PSI, and PWF, that is the bottom hole pressure, that is also in PSI. So all these terms we noted down. Then the constant, that is 141.2 into 10 to the power 3 multiplied by Bg. Now this Bg average is the formation volume factor. So formation volume factor, that is equal to 0.00504 into Z, T and P. This Z is the compressibility factor given to us 0.98. T has to be the temperature in Rankine. So here you see the temperature is given in Fahrenheit. You have to change it into Rankine. And pressure has to be in PSI. So you will be using the average pressure here, that is already given to us in PSI. So you will put these values here, you will get the value of Bg average. So that will be the value here, mu is the average viscosity that is known to us 0.027 in centipoise. It has to be in centipoise only. Okay, it's not given, but it will be in centipoise. And then ln 0.472 into Re divided by Rw. Now, Rw you are getting from the gas well diameter. If you do half of this, you will get Rw. And this Re, to find it out, they are already gave you the drainage area of 125 acres. So the drainage area of 125 acres, that you have to change into feet square, because you have to take the radius. So Rw is the wellbore radius. So Rw is known. So Re is the radius of drainage area in feet. So here it is, the area is given in 125 acres. You have to change this unit into feet square, and that feet square you have to equal to pi r square, because the area will be considered as circle. So when you will equal it to pi r square, from that you will get the value of Re. So that is this value. Okay. So all the values now known to us, we will put the values, and from that we will get the final value of flow rate in MSCF by day per day. That will be option C, 1570. Okay. Any doubts in this one?
Ma'am, that 6 7 by 8 inches, that is 6 or 7 by 8 inches.
It's like the mixed fraction, 6, 7 by 8. So it will be 8 into 6 plus 7 by 8. It will be
Okay,
55
ma'am.
by 8. It's like that. So any doubts in this one? I think in this assignment also you have questions like which are based like these equations only.
Ma'am, yes, we have a question, but that K value is not provided in our question.
The permeability.
Yes, ma'am.
Okay, let me see once. Mhm. Is there any way that you can find out the value of K through Darcy law? No, for that you will need the
Um,
flow rate.
yes, yes, ma'am.
Mhm. You can do one thing. You can ask this question in the discussion and mail it to the professor. He will be able to tell how to, like, you have to submit it tomorrow. You should have done it little before. But whenever you have doubt, put it in the doubt in the questions that are given in the assignment. Ask in the discussion forum. Then sir will it will directly go to sir, and he will be able to change the questions.
Okay, ma'am. Ma'am, discussion forum, where it is available?
There is a Q&A option comes on the top. You will see when you will go to the course. So above there are like announcement about the course Q&A, progress mentor and all. There in Q&A, I think you will be able to ask the questions.
Okay, ma'am.
Yeah, so you need the value of k. You have three questions in the assignment that you have to do. Try to write that. I will also maybe mail sir about it if he can answer something.
Ma'am, there are six questions, ma'am.
Yes,
We
ma'am.
Okay.
cannot
Six
solve these
questions.
six questions without k value.
Yeah. Yes, almost all, more than half of the assignment is based on that question. Okay, that's a serious thing. Okay, you write that in the discussion. I will mail to sir about this. Okay. Okay. So let's discuss these questions. So next question is the for the same data, they are asked to estimate the value of flow rate considering the pressure square approximation approach using analytical expression and round off the answer to the nearest one. So again here they are asking the pressure square approximation approach, which is this equation. So we will be using this equation but not considering the S and dq. So it will be this. As already we discussed in the last question, what all these variables are known about and what will be their value. We will put those values and again we can get the value of Q that will be around 1260. Now next question is to estimate the value of flow rate considering the pressure approximation approach using analytical expression with a skin factor of 5 and non-Darcy coefficient of 0.002 day per MSCF and round off the answer to nearest one. So here they have already given in the question the skin factor and the non-Darcy coefficient. So for this we need to use the original the equation which has included these two values. So here they ask to find the pressure approximation approach. So that is this first one. So here, as we already did almost till here in the last question, now S and dq value we have to add. And putting those values, we can find out the value of Q, which will come out as 950 MSCF per day. So option D is the answer. Similarly, in the next question, again the skin factor of 5 and non-Darcy coefficient of 0.002 is given. And they are asking the pressure square approximation approach. So the equation we know, which includes the S and dq values. By putting those values, we can get the final value of the flow rate as around 760 MSCF per day. So option C is the answer. Question number 7 is that there is a statement given which is assertion statement A that non-Darcy flow occurs in the near wellbore region of high capacity gas and condensate reservoirs. And the reason R is given as that as the flow area is reduced substantially, the velocity increases and the inertial effects become important. So options are A, that both A and R are true and R is the correct explanation of A. Option B, both A and R are true, but R is not the correct explanation of A. Option C, A is true but R is false, and option D, both A and R are false. So any idea what will be the answer for this question? What is the condition of having non-Darcy flow?
Option B.
Option B, both A and R are true, but R is not the correct explanation of A. Okay, not as purpose. So, so the statement A is talking about the non-Darcy flow and where it occurs. And option, the reason is actually the reason of why non-Darcy flow is occurring. It is because the flow area will get reduced and the velocity will increase, which will cause from laminar to turbulent zone. That's why non-Darcy flow occurs when it moves from laminar to turbulent. So if the velocity increases, then it will be turbulent. It will be non-Darcy flow. So for the statement, I think the reason is that only that the flow area is reduced. So option A is the correct one. Because the non-Darcy flow occurs in the near borewell region of high capacity gas and condensate reservoir, and as the flow area is reduced substantially, the velocity increases, inertial effects become important, and the gas flow becomes non-Darcy. So this was the statement which actually sir taught us in the class. So option A is the correct one, that for the given statement, the main reason why it is becoming non-Darcy flow is the reason that is given here. So both A and R are true and R is the correct explanation of A. Okay. So the next question is that in the drawdown test or build-up test, the actual QT, the flow rate time curve, always vary from the idle curve due to which of the options are there? Option A, skin effect. Option B, productivity index. Option C, wellbore storage, and option D, none of them. So which one will be the answer? That why during drawdown test and build-up test there is a difference between the ideal curve for flow rate time and the real curve of flow rate time. There is one statement that's pointed out at the bottom. That what is the reason that there is a difference in the curve? Anyone? Shrishti? Shrishti, any idea which will be the answer?
Skin effect.
No. Okay, so the answer is the wellbore storage. So sir must have told that whenever uh, we are shutting down the flow or starting it, there is always some liquid or gas always stored in the wellbore. So that wellbore, the gas or the fluid that is stored in the wellbore, because of that, initially there can't be an abrupt change in the flow rate. So flow rate will change like it will take a little lag with time. This is because of the stored fluid inside the wall-based storage, that whole line from the reservoir to the top. So that's why the curve does not follow the ideal curve because of the well-bore storage. Okay, so here you can see if it was ideal, then abruptly the flow rate will be changing. But as there is some stored fluid inside the wellbore, that's why the flow rate with time changes little slowly and by a little lag. So this is the ideal one and this is the real one. Next is the match the following. So first option in the left side there are four options given, that is drawdown test, interference and pulse test, isochronal test and build-up test. And the right side is given multi-well test, deliverability test and single well test. So we have to match these two with each other. So we know that there are two types of tests, that is pressure transient test and deliverability test. So pressure transient test is creating a pressure disturbance in the reservoir. We do the pressure transient test. And this has two types. One is single well test and multi well test. In single well test comes these four: drawdown test, build up test, pressure follow up test and infectivity test. And for multi well test it is interference and pulse test. Whereas deliverability test has three tests, that is conventional deliverability test, isochronal test and modified isochronal test. So from all these lists, now tell me, okay, already shown that which one will be the correct answer. So first they are saying drawdown test. Drawdown test comes in the single well test. So one will be matched with three. Interference and pulse test is the only one in the multi-well test. So it will option one. Isochronal test is a deliverability test, so it will be with option 2. And build-up test again comes under single well test. So it will again match with option 3. So you can see option D, 1 is 3, 2, 1, 3, 2 and 4, 3. So option D is the correct answer. Okay. So I think the questions in this assignment are somewhat similar to these questions only. Only problem is with the permeability constant, that we have to see. Okay, any doubts in these questions?
No, ma'am.
Okay. Okay then. I will mail sir. If you can, you can also mail sir. You will find his ID online. Otherwise, put this question in the question answer discussion forum, that this value is not given and what to do about the assignments, because you won't be able to solve those 6 questions in assignment without that. If you put the value of k, no. Mm, we need the can't assume it. Okay. Then from my side, the discussion is over for the sample questions. Okay. So if you have any other doubts, you can ask or you can leave for this session and also put your question in the Q&A. I will also mail sir about it. Okay.
No, ma'am, no doubts.
Okay. Then you guys can leave. The session like one is over. I will wait if somebody else joins. Otherwise, that's all for my side.
Thank you, ma'am.
Welcome.